Okay. This room has less echo than the other one, so that's good. So my name is Dimitris Andreadis. I work in Red Hat. I've worked on the application server space for many years, 15 years. JBoss, Wildfly, JBoss CAP. I was running those projects. But now I'm doing something different. So now I'm running a couple of teams that are doing cloud-native Java. And this includes projects like Vertex, Thorntail, and now Quarkus. So who has heard of Quarkus before? All right, good. Well, you got a T-shirt. And this is the first time we give away T-shirts on a conference about Quarkus. So it's collectible. You know, keep it for your children. You know, it will have value. Okay, so what is Quarkus? It's a software stack to help you write cloud-native apps. So really, we're talking about microservices, serverless, this kind of stuff. And we want to make Quarkus fun. We want to make it fun for the developer to develop in Quarkus. In the JBoss days, we used to say, put the developer back into the driver's seat. So that's what we have in mind again. We want to go supersonic, subatomic, so very fast, very small. You'll see more about this. In Quarkus, we also want to unify the two programming models. So if you like standard, imperative code, that's fine. If you want to write reactive, we want to make this easy for you as well. Let's do an exercise. There are people coming. So if you have an empty seat next to you, just raise your hand so people can go and find the seats. Yes? Yeah, nice. Thanks. And Quarkus is both old and new. So the framework, the core Quarkus framework is new, but all the pieces we're using, they're proven components, very popular libraries. There are some more seats in the front if you are looking for them. So what's with the name? Well, it's the hardest problems in computer science, pick up a proper name, but Quarkus really implies small, quarks, the subatomic particles that make up protons and neutrons. Us, developers, you can make funny verbs with quark, now I'm quarking you, and you'll get quarked, and you might write quark-enabled applications. Now, it's kind of interesting because today it's a 3-month anniversary of Quarkus. So exactly 3 months ago, March 7th, we released Quarkus to the public, and it was done from this room in Switzerland. This is part of the Quarkus team. And for me, it was a very nice experiment as well, because we were used to, independent teams working on their projects, but Quarkus was the first time we actually assembled an interdisciplinary team to work on the same problem. So we have people from, the GraalVM, frameworks, kernel, runtime, security, performance, to tackle this one, really annoying problem. What's the best way to write cloud-native apps in Java? Because, Java is our bread and butter. You're all Java developers or related to Java somehow, and there are 10 million programmers in Java in the world. So how can they transfer their knowledge into this, new, brave cloud-native era? Let me take a step back. So application servers, I know a lot about them. I've been working on them 20 years now. in the early days, if you remember, to run your stuff on the application server, you had to precompile your stuff. You had to generate stubs. So in order to get access to the functionality of the server, you run this step where you generated this code that will attach to your code and then connect you to the facilities in the server. So the transaction manager, persistence, logging, security. And back then, JBoss was the first server that came and changed this. So in JBoss, what we did is we took advantage of the dynamic proxy facility in Java that was very new. And instead of pre-generating everything, we did everything at runtime. So you deployed your jar, and we open it up, examine it, generate code of the fly, wire things together. And this totally changed the way application servers worked. And since then, all major frameworks do something similar. They do lots of stuff with the dynamicity that Java provides, which is excellent. And it gives a lot of power in all those frameworks. Then we went into microservices, like 5 years ago or something, where we start breaking out functionality from the application server into smaller projects that can be deployed independently. It makes things harder, but then you can scale those bits, on their own. And that's the modern trends for greenfield development. And this goes on and on. So how many do serverless now? Anyone? Not many, okay. It's still, picking up. But the more you go to the right, the smaller you get. Because now you can scale down to 0. There's an event coming. Code will be spawned and then react to the event and die. But what's very evident is that the more you go to the right, the smaller you get. Density is important. You pay for memory, you pay for CPU. So it's important to go smaller. And the truth about Java is that the JVM has been an excellent environment to write applications. Very optimized, secure, mature, tons of frameworks, but they all come at a cost. The cost to keep those classes around, introspect classes, do JIT compilation, just-in-time compilation. It takes energy, it takes processing. And when you see how we deploy applications in the same space, you can deploy, X number of apps, microservices, whatever, on the JVM. You can do more with Node. You can do even more with Go, with native code. So size matters. And if you look at the numbers, who's doing serverless, what are they using? Node is king. Python comes next. People start writing more and more Go because it goes well with the Kubernetes environment. And Java is really at the bottom. It's not really the best language to do serverless and Knative. So we've been looking for solutions, and many others. And at Red Hat, different teams have tried to solve this problem from different directions. So we've worked in the standards. So with other vendors together, we created the Eclipse microprofile effort to produce specifications for cloud-native Java. Is there anyone using microprofile? Just very few, unfortunately. Parts of the microprofile now we try to incorporate in Java EE. On the runtime side, we try to minimize the application server. We did experiments. We were running Wildfly on Raspberry Pis. We modularized. We made it very efficient. Small images to run on OpenShift and Cube and all this stuff. On the Linux side, the GCJ project was a very early attempt at ahead of time compilation, so turn bytecode into native. So that was years ago, you know, a long time ago. So it was really ahead of its time, so to speak. And OpenJDK as well, they were looking at ergonomics, metadata reduction, all sorts of things. But the truth is that none of these efforts actually made huge difference, you know, small differences. And we always felt that really the issue is in the JVM. Unless we tackle this in the JVM, we can never get really small. So that was until now, because Graal came. Have you heard of Graal? All right, good. So Graal is a project that was running as a research project for 7, 8 years or something. But recently, it's 1-2 years that they have actually produced some very impressive results. And they open sourced a big part of the Graal ecosystem. And when we talk about Graal, it's a lot of things. And if you are not really into compilers and stuff, it can be very confusing, I can tell you. So I'll try to explain a few key things for this discussion today. At the core of Graal, we have the Graal compiler. So the Graal compiler can do JIT, just-in-time compilation, and it can replace essentially the C1, C2 JIT compilers of Hotspot. So when you run Hotspot, you have the C1 client compiler and the C2 server compiler, and they do their magic. So at some point in Java 9, I think, the JVM CI API was introduced, JVM compiler interface that lets you plug in a different JIT compiler. And this is where Graal attaches to the VM. Now the thing with Graal is the compiler is written in Java. And that makes it a lot more accessible to maintain it. The C1, C2 compilers are C, C++. They're super optimized, but they have reached their limits of how far they can go. So the theory is that with the compiler written in Java, we will have more possibilities to optimize this. So that's one thing. Now, the other interesting thing is the compiler can also operate ahead of time. So you can take your classes without the program running, and you can pre-compile them. And the native library, you can link it, or you can show it to the VM. So when it starts, your code is already pre-compiled, so it will start faster. Yeah, so you can do that with the Graal compiler. So that's the Graal compiler. The other interesting bit is the substrate VM, which is it's a VM written in Java in a subset of Java. Why subset? Because anytime you do AOT, you cannot use all the facilities of Java, because Java is quite dynamic, but to do AOT, you have to take out the dynamicity of Java. So it's written in a subset. It includes the basic VM stuff, like a scheduler, thread scheduler, garbage collector. And it allows you to pre-compile your Java application into native code together with the Graal compiler. But Graal goes, many steps further. There's all sorts of stuff about truffle. I won't talk about this. But the cool thing about Graal is, if you have your full code, you can do analysis and find out what are the call paths that are executed, who calls who, in fine detail. And when it does this analysis, it can take out all the pieces that are not used. Something similar we had with Hotspot and the linker, in which you could produce essentially a VM that's specific to your application. But that in Hotspot, that was done at the module level, so it's more coarse-grained. In Graal, you get down to the nitty-gritty detail. You know, this field is not accessed. I can't get rid of it. So it's a lot more, you know, detailed. But there's a problem with Graal. It's too complex. It's hard. It's hard to use Graal because there are things you can, in AOT mode, right? You don't do dynamic class loading. You forget about this. No invoke dynamic. No security manager. And some other stuff like reflection, dynamic proxies, JNI. There are limitations, and you have to configure them. You have to tell the compiler, I'm going to do, you know, reflection here. So be prepared for that. So it's hard. It's hard to do Graal properly for your code, and even more difficult for framework code, because when you write an application, you use, you know, 50 different libraries, and it's almost guaranteed they're doing reflection, dynamic class loading, because Java is so dynamic. So everyone was overusing those facilities over the years. So this is where Quarkus comes. So Quarkus comes to solve this problem, how to do Graal effectively. So what is Quarkus? Quarkus is a set of tools, Maven-enabled tools. There's a lot of internals. Some of them are very complex, so I don't want to get into too much detail. What is interesting in this discussion is that Quarkus have a core and it has extensions. So for every framework that we want to enable for Graal, we need to have a special extension that talks the Quarkus SPI. So Quarkus drives all this process, and as it discovers the various pieces of software, it calls the extension and says, oh, you know how to do Hibernate. So, all right, let's work together to do Hibernate with Graal. So the extensions do all the heavy lifting. And the good thing about Quarkus is the end result. Of course, it can lead to native code, executables that you can run on their own. But it's also great for hotspots, because the optimizations we do for Graal result in smaller, faster Java code. And I'll show you how that works. So in Quarkus, what changes is in the normal Maven build process, we have some extra steps. We have a provisioning step where we collect all the dependencies. We bring things together. In the future, we hope to be able to patch things after they're produced. So things in production, you know, there is a CVE, a security patch, and we go and fix it there without having you to precompile or, you know, do the whole thing again. So this is coming. Then it's the wiring and assemble phase. What happened? And I've lost the video. Is there something I can do from here? Or I can keep talking until this is resolved. So this wiring and assemble phase where we do the Quarkus magic. So I can try to explain to you how that looks like. Imagine you're a framework, you are Hibernate, and you want to Quarkify an app. What you do? You have to find your configuration files, XML files, read them, read the code, read classes, discover annotations, build a meta model in memory, and then start and go and create objects, create proxies, wire together the code. And after you do all this, yeah, it's coming? Okay. It's just this one that doesn't work. All right. And after you do this, then you start the application. So there's a lot of work. But the idea that came to us was, why I have to do this every time I run my application? Why I cannot move most of the initialization phase at build time? So that's what we're trying to do. Should I go on with the slides or? Yeah. So we try to move everything at all the initialization at build phase. And essentially what we do then is the end result of this initialization. So for your app, I have to create those objects, and that's it. This is what we leave inside the application, only the part that needs to be executed. And that also benefits hotspot. The magic comes when you compile this for native. Graal will actually execute this at build phase. So when the application starts, this is all done. The state is already in memory. It's all there. What's remaining? Yeah, I don't know what this window is in the beginning, in the middle. Can you remove this thing, please? Logokritia. I cannot talk about Quarkus. Reboot always helps. It looks fine on my screen. Well, you just come here and look at my screen, okay? I'm not sure what can I do. I can keep going. All right, I'll keep going because there's not much time left. So I will describe you what's the end result. The end result is you get a traditional, microservices app, takes X amount of memory. You quirkify it, it takes half the memory. You go native, it takes a fraction of the memory, like a tenth maybe, or a fifth. And that works also for bigger apps, not just demo apps. So you can imagine that you can bring down the memory utilization to half or a fifth or a third, and even more important, the boot time is you can see some of the slides there. It goes really, really, really fast. Now, the rest of the demo, I have to do some coding here, but I'm not sure you can see it like this, so this has to be resolved before I can go on. Is there any hope there? Oh. What should I do now? I don't know. I'm out of ideas. Should I do this? Oh man, that's hard. Καλό δύο. It's still there. Doesn't gonna go away. So now we have to work under heavy constraints. Oh, man. Is someone working on this actually now, or is it just me? Yes. Well, the idea is that I want to show you how you do some coding here, but there's not much space on the screen. So you have to imagine that yes. It's a bit hard, sorry. Ella? Okay. Yes. Yeah. Then ορίστε. Δεν είναι, οι πίσω οθόνες δουλεύουνε. Είναι αυτό που λένε, αν κάτι μπορεί να πάει στραβά, θα πάει. Πήγε. Okay. All right, we're back in business. So a little quiet, please. All right, so to get started with Quarkus, you go to our website, everything is there. The easiest way to start is just to start with an archetype. So that's what I did here. I just created a project like this, Maven Quarkus create, and I just compiled the project and open it up in this editor. So it's a very simple microservice, okay? The interesting bit is you can see this is just standard Java EE. There's no special Quarkus magic. I've compiled it, and I should be able to run it. If you see what's produced, and I hope you can see the screen, right? Yep. So there's the runner jar, Java minus jar, target, microservice, runner. So That's how you can run it. So that's a basic microservice, all right? It starts quite fast, 0.8 seconds. That's hotspot mode. And I can check it's running. I can go there and check, okay, localhost, is it running? Yes, so Quarkus is running. The way we develop in Quarkus is we start the plugin in dev mode. So in dev mode, the server is started in the background, and I can start coding. So if I go back to my IDE, so just prints hello. Let's see if this is working here. So hello. Yep. Here, so it's listening. Now if I go back there and do some, change the message. Hello, Voxxed Athens. So save, go back, refresh, and it's there. So this is Java, right? So, so what happened? What happened is that in dev mode, the server is running. A request will come, so we hold the request, and then we check the file system to see, is there any change? So, okay, there was a change. I changed the Java file. So we recompiled the file on the fly. We stopped the server and restarted the server. And it took like, less than a second to do that. So let's do that again, just to realize, some exclamation marks, save, go by here, refresh. So this is Java development. It's just JavaScript. It's not Python. This is straight Java. OK. So the way to continue with Quarkus is you can check out, OK, what other modules I have, list extensions. So Quarkus will list you what else it can do. So there are different extensions here to do various things. Those are also documented on the website. So if you find something interesting, let's say I want to do some JSON processing. Okay, so then I can say, add this. Where was it? Here. Add this extension to my application. And there's no really magic here. What it does is it goes into the POM, and it sticks the new extension. So there it is. I have a new extension, and then let's try quickly do something there with that. Okay, Voxxed Java. Let's fix it. Who uses VS Code? All right. Location. Your public Voxxed. It's a bit hard here. I'm sure there was a way to do this automatically. No. This location. Let's generate a couple of setters. No, not that. All right, just an example. All right, that should do it. So then I can go in my resource and add the new method. Let's try to output this, produce this, and produce some JSON. Voxxed turn. Oh yeah, forgot this one. All right, let's see if this works. So go back here, Voxxed course, it doesn't work because I'm not running the server. Yeah. And it doesn't like it. Failed to start Quarkus. Yeah. I have it here. Pules. Bauch. Yeah. Have to compile the code. Yeah. And now it's here. Phew. All right. All right. So that's how development works. And at the moment you are ready, you develop your application, you want to debug it, whatever, and then you want to go native, you say, okay, compile this thing. Let me check something first. I have to fix my tests, right? Yeah, make sure the test works. Yeah. And use a native profile. So at this point, the Graal machinery will kick in and it will do its magic. This will take more time, as you can imagine. This is a 4-year-old laptop. So let me go back to my slides. So again, what you missed before were some benchmarks. A REST app, traditional Java stack, you can imagine which it is. With Quarkus, make it smaller. And with GraalVM, even smaller. Same with a normal REST application that does database updates. And the boot times, which are just insane in native mode. So developer joy, this continuous mode where you code, you see the result of the code immediately, things that you normally do with dynamic languages. We also try to unify the model, so offer the traditional imperative mode. Most people are using that. But if you're doing reactive, at the core of Quarkus we have Vertex, and Vertex drives all the reactive functionality. So what we want to do is, for most APIs, offer a reactive equivalent. So you have both options. And best breed of frameworks and standards. So we are not dogmatic with Quarkus. We try to embrace the standards that make sense, embrace de facto standards, frameworks that are very popular. For many things, we have written extensions to enable them for Quarkus, but we also expect the community, you guys, framework providers, to write extensions to Quarkus to essentially enable applications for new cloud-native universe for GraalVM. That would be great. So if you want to learn more, tomorrow, 3:30, there is a session by Yanis, 2 sessions by Yanis and George. Can you raise your hands, guys? Yes, it's here. They're here. They will be next door, and we'll show more coding on Quarkus and Quarkus internals. It will be interesting to see how we can fit you in the next building. So be early. Yeah, so compilation was finished. On my machine, it took 2 minutes to 12 seconds. So what you get there is, in the target directory now, I have a native image. So in this image, we have the code, the frameworks, and the parts of substrate VM. So let me try to run it. Target microservice runner. It starts in 7 milliseconds. And I can verify it's running. Yeah, it's there. Yeah, and I can go faster. Sometimes if you refresh and the file system is hot, 6 milliseconds. Okay, so that's quickly what Quarkus does. We had a lot of, problems with this session today, but I hope you get an idea. We can take a few questions. Yes? Yes, we can take some questions as well.
So speak up.
Is there any trade-off of using only the native image mode, let's say, instead of the open JDK?
Yeah.
To rephrase, a native image seems so cooler, so they're so smaller.
All right. Why use native or not? All right. It depends on the type of applications you want to create. So for serverless, obviously, native is the choice. For longer running applications, hotspot is still faster. It's probably 20% faster, but it takes more memory. So things that will be longer running, they're fine on hotspot. If memory is your thing, you can go native if density is the problem. Other things, of course, with native, if you have to debug, it's a native application, right? It's not Java anymore. You have to use native tools and language and tools to debug it. GDB, stuff like this. You can definitely get more performance, more per megabyte if you go native, because in the same space you can run, 10 more times processes. What other differences? Those are, straight off my mind. So it's okay to run hotspot. Hotspot is great. I'm not, I'm not bashing hotspot. No. Other questions?
I'll go around with Mike.
Hi. I would like to know whether for these extensions that you have written for the various frameworks, do they support all the features, let's say, of Hibernate, meaning that how GraalVM friendly is Hibernate, and how much are you able to help with making it GraalVM friendly via the extensions? Are there some features that will not be supported, Hibernate features that are not supported, let's say, when you use Quarkus?
Yeah. Well, I don't know the exact answer to that. I know Hibernate was one of the most difficult frameworks we had to enable. I think we were successful. I'm not aware, maybe George or Yannis, do you know any case on Hibernate that doesn't work?
Personally, I haven't heard of anything that doesn't. Hi. Yeah, in general, there might be cases like in GraalVM, you can't do like dynamic class loading, right? So if your framework is going to do that, that's not going to work. But for frameworks that just do like reflection and JNI or whatever, that will work, and Quarkus makes it a lot easier for framework developers to do that.
There have been cases like if you write a microprofile app, because we support most of the APIs, there were cases people just moved their app over Quarkus and it just compiled, right? Because all the things were in place. For other frameworks, we will need to add more extensions. But Quarkus really handles the complexity, even behind write an extension. So if you write an extension, you essentially initialize your app through the Quarkus API so that Quarkus can check what you are doing and is able to replay those things at runtime and for Graal to make compilation easy.
And we have time for one more question.
There's one in the back, like.
I can't run that fast. I'm with heels.
Okay.
How about the Spring Boot?
How about Spring Boot? Okay. I thought I would get that question. Yeah. So currently we support the basic injection. Yeah. You can do basic Spring Boot for now, but to do anything more advanced, we will have to write extensions. We're not looking into this right now because we don't have a lot of resourcing. It's also a matter of the Spring Boot community, you know, how much they want it, how much Pivotal wants it. I think we would be glad to see Quarkus being the enabler for Graal because it has a very nice architecture and it's extensible. We will see. So for now, you cannot like take your Spring Boot app and just Quarkify it. You have to use some different APIs.
Great. Thank you, Dimitri. Big round of applause for Dimitri.